Okay, can you hear me? Yes, very good. Okay, we're going to start with this seminar. I am very happy to be hosting this event. We are in the context of the 15th Latin American Congress on Plant Physiology, which is in the National University of Cordoba. It's 405 years old and the oldest university, one of the oldest universities in all America, and my alma mater, so I'm very happy to be here. Before starting with the speaker addresses, I'm going to introduce a little bit of some local context of the seminar. The topics are open science, reproducibility, and preprints. But I thought I should say something about that in our context, in a regional context, and in Argentina in particular, most for the speakers. So in 2013, in Argentina, there was a sanction of a law of research repositories, digital repositories. The essence of that law was that every research output that was developed by funding from the public sector should be available to the people. And in Argentina, almost 90% of R&D spending is public, so it's a very important piece of the cake. In that context, the government initiated a series of 25 repositories that now harbor about 125,000 research outputs, which are available to everybody. But there are certain issues, and many of the research outputs of our researchers are still behind paywalls because of the copyright transfer and etc. in the publishing landscape that we have. In addition, that law was followed by another law 2 years later about open government, and that also includes a sector of national systems of data, also genomic and biological, and some funding to increase the uptake to keep and update those databases. So that's a kind of incentive of to have more of the research generated by our researchers available for the public. We are experiencing some strong spending cuts in research in Argentina, and that's in parallel with very strong devaluation. So besides that, our salaries have been liquefied. Also, the power purchase of our grants is very meager now. So we are shifting a little from publishing in journals that are not based in open access, based in article processing charges, and we're shifting more to subscription journals where are usually free, but then thus we are increasing the amount of material that usually ends up behind paywalls. So one of the avenues to try to follow the essence of that law, it's an opportunity. It's preprints, and because well, the open access accessibility of the research which are posted there. But in Argentina, in the life sciences, we are not preprinting. There are only about 200 research outputs posted in bioRxiv with Argentinian researchers, and that number gets to a couple dozens if you only count research groups that are all from our country. So I guess that most of our research outputs that are posted in bioRxiv, the decision to post there might be derived from collaborators from abroad. So in me as an ECR, I'm trying to promote the use of preprints in Argentina, and with a couple of fellows also that I met in the Life Ambassador program. We are trying to advocate for this, for the benefits associated with this in a local context and also abroad. So that is kind of the context right now around here. Well, I'm going to introduce the first speaker. I am very glad to have here Dr. Casey Greene, who is an assistant professor of system pharmacology and translation therapeutics in the Perlman School of Medicine at the University of Pennsylvania. His lab develops learning methods that integrate distinct large-scale datasets to extract the rich and intrinsic information embedded in such integrated data. This approach reveals underlying principles of an organism, genetics, its environment, and its response to that environment. Regarding the focus of this seminar, Dr. Greene is an instigator, in quoting him, who did some real-time peer review, which I use another word there, an instigator of the Bio Overlay Preprint peer review platform and the collaborative authoring tool ManuBot, and has championed with colleagues interesting initiatives such as the Research Parasites Awards, celebrating rigorous secondary data analysis as a key role in the scientific ecosystem, encouraging reproducibility and open science practice. Ladies and gentlemen, Casey Greene. We cannot hear you.
There, is that better?
There you go.
Perfect.
Okay.
So hopefully you can see the presentation. It looks like it's showing up to me. So first, if you want to drop me an email, I'm happy to send you these slides. Feel free to reuse them under a Creative Commons attribution license. So I want to spend some time kind of talking about a couple projects that I was part of, maybe a little bit of an instigator in terms of doing them, but really I think a lot of the work was carried out by others, and so I'm sort of conveying on their behalf what we've been up to. And they're both sort of centered on how we read and contribute to the scientific literature. In the first case, I'll talk about a paper that we wrote entirely in the open that sort of had review ongoing. And in the second case, I'll talk about some ways that we're using preprint servers to try to push the publishing practices forward. So about 2 years ago now, I got asked to write a review for a journal called Journal of the Royal Society Interface. And they were interested in the intersection between deep learning and precision medicine. And instead of writing the paper, because that's, seemed like a lot of work, I started a GitHub where a group of people would sort of assemble and write this paper together. If I had known then, it would be a huge amount more work. Maybe it would have gone differently. But I think the outcome was really sort of interesting. Even if you're not interested in, say, deep learning or genomics, I think the process provided some lessons for how we can take advantage of the global community's expertise to do more rigorous science. So the way this process worked, people went in, and in GitHub, you can sort of create issues. So an issue is sort of a thing you want to discuss. And so people created these issues, and then we talked about various topics within those issues, and then eventually we started writing a manuscript based on the discussions that went on in those issues. And to end up as an author on this, you had to both participate in the discussions and also contribute to writing. So people who did both were offered the opportunity to be co-authors. And then nearly everyone, but not everyone who met those criteria, elected to become a co-author. So we ended up writing this paper. It's available. If you want to read it, it's on. You can find it on the web through GitHub. You can also find it at bioRxiv. Although now bioRxiv doesn't allow review papers, so we wouldn't be able to put it there again, but it happens to be there now. I'm sure Richard can mention something about that later. And we ended up with about 40 people who contributed to the article itself. One of the nice things about writing this thing in the open is you can sort of see how the process happened. I will note, when we started writing this, we had no software to actually build it, so we both wrote the paper and built the software at the same time. So the postdoc in the lab who built most of the software is Daniel Himmelstein. This is how the writing proceeded. So we actually started this paper back in August. We really contributed the first text in October, and then over the first deadline for the paper was essentially the beginning of 2017. So you can see we missed that deadline. The second deadline was April, so you can see we missed that deadline too, all review papers. And then the third deadline was July, and so we did hit that deadline. So you can see these sort of spurts of writing that come around the times of deadlines. This was the initial submission of the paper back in July, and then underwent peer review, and then in, I think, maybe November or so, we got reviews back, made some revisions, and then the paper actually was just published this year. So this is sort of how the process went. And using this sort of online authoring system, you can actually attribute, I think these are words, so the total number of words that someone contributed to the paper in aggregate, so including words that were either added or removed. It was kind of interesting to write the paper this way. So one of the things that we ended up with was actually a really extensive kind of description of an area that was sort of exciting to people. And at the end of last year, Nature wrote this article on 2017 in review, and they had in that a table on popular papers of 2017. And so in the April to June window, our review was actually apparently the most downloaded paper on bioRxiv. So that was kind of fun. And we asked Richard for some more stats, and we think we might be the most downloaded paper of last year, which was just kind of interesting, of this sort of experiment where 40 people came together and ended up just writing this paper online. But I think one of the lessons that we took away from it was that being able to write online is sort of a powerful way to sort of free what often goes on behind closed doors. And it might be useful sort of if you're thinking about an environment where things are moving towards subscription publishing. This provides a way to do most of the writing in the open, so that the value is still publicly available, even if the final product ends up somewhat locked away. And so the system that Daniel actually built to do this, so Daniel Himmelstein on the bottom right is the postdoc in the lab who really wrote the software behind this. And the idea was, when you write papers, what if you wrote them like people write software? So you don't have to actually write software, but you write them in Markdown. So Markdown is a plain text form that supports things like hyperlinks and lists and emphasis, so bold or italics, as well as headings. So you can write Markdown. It has a link here. So I don't think my pointer is showing up. So this, in the top line, there's something that says deep review in Greene, and that's actually a link. And you can also handle with Manualbot the citation situation. So if you look in the Sci-Hub coverage study, there's a part of that line that says @DOI, so it's at digital object identifier, and then it lists the DOI, and so you can actually cite things by permanent identifier within the system. This is what it gets converted to. So you write that Markdown text. It ends up looking like this. So this is the rendered version. And then the bibliography is constructed for you automatically. So if you've done sort of bibliographic management, you know that maintaining a library in some commercial software packages, sometimes it gets corrupted. So we tried to avoid a need to maintain the library. So we actually recommend doing citation by persistent identifiers. So in this case, DOIs, which the Manualbot system then automatically fills in with a bibliography. And the idea is the DOIs should either not change, or if they change, they should only be corrected. Currently it supports DOIs. For those in computer science, it supports archive. For those in medicine, it supports PubMed IDs. And it also supports just plain URLs. And one of the nice things about writing this way is you can actually see each of the changes. So this is just a quick fix that Daniel made in a different manuscript where he realized that he had misnamed one of the fields in a database that he was using. This automatically all gets rebuilt. The system is free, so it uses GitHub, which is free for open repositories, and Travis CI, which is free for open repositories. So you don't have to pay anything to use this, and the software itself is free. So it will rebuild the document, and then it gets sent back to GitHub. So that means it's put back online for anyone else to read, also for free. So it essentially can make it makes your lab or you or your group of people you're working with into sort of your own publishing platform. And Daniel likes to look at it's proof of existence. So the idea that this version of the manuscript existed at this time, and the timestamped on the Bitcoin blockchain. So it also gives you this proof of existence that might be important in science. So it's not like you're recording that the manuscript existed. It's sort of immutably recorded on this global record. And it's worth noting this is also the way that this is done is actually free, since it uses open timestamps. So it's not like you have to pay each time you update. And we recommend writing with this sort of model where people provide a contribution and it gets actually reviewed at the time of the contribution. And then once it's considered accepted, so it almost moves peer review, though it's only among authors, much earlier in the process. So each part gets reviewed before it gets added. And we think this is part of the reason the system has helped write manuscripts that are that seem to be widely read. So there's a second. Last year, Daniel wrote a second manuscript using this system on Sci-Hub. So this one was also downloaded. I think it was downloaded about 50,000 times, so similar to the deep learning review. But again, it was all available online as it was being written. And if you want to see what Daniel's been up to this year, he wrote a proposal for what he was planning to update with Manubot with in 2018. So that's also online. And the Sloan Foundation actually is supporting this now, so there will be there are sort of advances and ongoing development right now. And then I just want to sort of talk about one other initiative that I think is potentially helpful for academic publishing. So in the previous part, what I was talking about was sort of a way to make publishing more open and accessible at no charge. But I think putting your work out there is really only half of the battle, right? The other part is the community needs to read it and participate in discussions around it before it sort of becomes considered like a bona fide part of how we understand the world. And so the beginning of this year, I and a few other people were excited about the transition we saw in terms of people moving a lot of their work to bioRxiv and posting before publication on bioRxiv. But what we saw missing there was the commenting culture. So it was a place to share work, but not so much discuss work. And one of the things that we thought might help would be to create the expectation that when work is shared in these services, that it will be talked about. And so to do that, we started something called BioOverlay. So it's an overlay for the life sciences. The idea is editors will come along and they'll pick a paper or preprint that they think is interesting. They'll actually send that out for peer review. So they'll basically think of people who they think would be good reviewers. They send it out to them for review. When the reviews come back, they collect those reviews. They write a summary of sort of how their thinking has sort of stayed the same or changed based on those reviews, and then they publish that. So it's a way to really try to advance the conversation around preprints to make it resemble a little bit more what happens in the traditional publication process. I will note that authors don't get to submit their work to BioOverlay. So part of what the editor gets is the discretion to choose the most interesting paper to them. And our hope is that this creates sort of additional conversation around sort of the papers that are most important that are showing up on either as published papers or on preprint services. So I'll just take you through what one of these looks like. So this is one, the associate editor in this case was Stephanie Hicks, and the paper was Multi-omics Factor Analysis, a framework for unsupervised integration of multi-omic data sets. So she talks about why she selected the article. So she was interested in factor analysis in terms of finding sources of variability, as well as methods to integrate multiple types of data. She summarizes the reviewer's feelings. So you can see in the sort of paragraph at the end, both reviewers found this paper to be of potential interest to a wide community of people. Both brought up questions related to the methodology, implementation details that could be expanded on. So it sort of does, it's sort of like an editor's note, but with a little more level of detail. And then below this, there's actually the reviews. So this is one from David Riso. So this is actually for the same paper. So this manuscript is well written and the method is statistically rigorous. So it looks a lot like the types of reviews that you get on papers. And one of the things that we're hoping to do with by overlay is really try to start to reduce the barrier between what is a preprint and sort of what has entered the scientific conversation by encouraging that conversation to happen in a robust and rigorous way. And so this is sort of our effort to advance that. Our goal this year was to publish 12 of these, so essentially one a month, and I think we're reasonably close to that. One of the things we're really thinking about now is how to expand the network of editors to cover more of the literature. So if there are people who are interested in participating, either as editors or being considered in the reviewer pool, please drop me an email so that we can, help to sort of push this type of conversation forward. And then finally, I just want to take a couple minutes to thank the people who made this possible. So the ManuBot work was done by Daniel Himmelstein. So he built the software that let us actually build that paper as the paper was being written. For by overlay, I want to thank, so there are 3 managing editors. So one is me, one is Stephanie Hicks, and one is Zach Hensel. So the group of us sort of try to keep the journal on track, or the overlay on track. And there's a lot of other associate editors who sort of send papers out for review and write summaries. So we couldn't do it without all of them. And then the work that I talked about here was primarily funded by the Gordon and Betty Moore Foundation. And I'm happy to take questions if you guys have them.
Oh, can you hear me? Yes. Okay.
Yes.
Yeah, we have a couple of questions here. It's about, you have mentioned one of the papers that you have written using the manuscript tool, which is the Sci-Hub provides access to nearly all the scholarly literature. I'm kind of interested in if you can comment a little bit of what you found there and the implications of that.
Yeah. So there's a few ways to evaluate Sci-Hub in terms of its completeness. One is just to ask how much of the literature is contained within it. And that number is much lower than what we actually think it can cover. So we chose to define coverage as papers that were recently cited. And we asked how many of the papers that were recently cited, what proportion of those are available via Sci-Hub. So we estimated that's about 96%. If you just do coverage, it's lower. I think if you do closed access papers, it's somewhere in the 70-ish% range. But that doesn't necessarily cover the fact that some people may not have ever requested a paper. So we think the citation metric is probably closer.
Okay, and you have mentioned, I don't know if I understood correctly, about using blockchain as a timestamp. Do you think about it might have any potential for priority claims in the future, that kind of technology?
Yeah, so I'm not a huge fan of timestamp-based priority claims, but on the other hand, we did implement that because we know that scientists care about sort of the time that something occurred. And so, yeah, you could imagine using it for sort of establishing priority, or at least saying that this certain form of this document existed on exactly this time. Since we use open timestamps, what that lets you do is publish for free. So you don't have to make a Bitcoin transaction. But it does mean that there's essentially something like a 0 to 30-minute lag. So, if you're really in a priority battle that's down to the seconds, it won't help you with that. But 30 minutes is, we thought, reasonable to get it for free.
Okay, and the last one, if you can comment a little bit about the Research Parasites Award and its interface with reproducibility in science.
Yeah, so I should put in a slide or two on the Research Parasite Award. So a few years ago, we started a prize for people who had reused other people's data in interesting ways. And so that ended up, for various historical reasons, being called the Research Parasite Award. And we've now given out 2 of them. We have a 3rd winner selected, which will be announced in January. And it's a prize for people who have used other people's data and then made the intermediate results available in a way that enhances their reusability. So, it's our hope that some of the people who win the Parasite Award will still go on to then be parasitized, I guess. There's also now a Complementary Research Symbiont Award, which I really like, from Brian Bird. And that award is focused on recognizing people who shared particularly well. So if you shared data well, you have a chance to win this award. And that comes with a cash prize and some other benefits. So I think it's, I'm glad that we're recognizing innovative reuses, of course, but also I think recognizing sharing is a complementary part of that. So I'm glad they both exist now.
Okay, thank you very much, Casey Greene, for your presentation. I'm accepting the invitation to be in this seminar. Okay,
yeah,
I'm going to introduce our next speaker. I'm kind of excited about this. So I'm going to quote one Argentinian writer, Jorge Luis Borges, and his paradox. He says, well, I usually get invited to a conference and they start introducing me and they say, there is no need to introduce this person, and they keep doing that for 15 minutes and everybody gets tired and everybody leaves. So I'm just going to try to do a very short intro about very specific highlights about Dr. Randy Wayne Schekman, which is a cell biologist at the University of California, Berkeley, former editor-in-chief of PNAS, currently serves as editor-in-chief of eLife, an open access journal funded by the Wellcome Trust, the Howard Hughes Medical Institute, and the Max Planck Society. He's a member of the National Academy of Sciences in 1992. His groundbreaking work on cell membrane vesicle trafficking led to a Nobel Prize for Physiology of Medicine in 2013. His study transformed the secretion field, previously descriptive and morphological, into a molecular and mechanistic one, as stated in his nomination as foreign member of the Royal Society. As a highlight, he donated his share of the Nobel Prize money to create an endowment share in basic cancer biology at UC Berkeley. Regarding the focus of this seminar, it is worth mentioning that in 2013, Dr. Schekman called upon for an academic journal publishing reform and the promotion of open access publication. He emphasized it in a Remember editorial in The Guardian about the journal impact factor as a flow measure and its exploitation by luxury journals which discourage replication study. Thank you for being here, Dr. Randy Schekman.
Well, thank you very much, Humberto, and to my colleagues, Casey and Richard, and in particular, greetings to my friends in Argentina and in South America. I'm very aware of the financial crisis in Argentina right now with respect to the funding of science. In fact, I just signed a petition to the government of Argentina, really protesting the rather drastic treatment of scholars, which will really sacrifice the standards of science going forward unless this is corrected. So I wish you all well, and of course I will address my remarks specifically to the question of the costs associated with scientific publishing. Let me first start by giving a brief review of the origin and the development of the journal eLife and why we did this and why we feel going forward it's so important, at least in the traditional model of publishing, which I find that I'm in the unusual position in this panel discussion as being representing the more classical model of publishing in contrast to what Casey and Richard will discuss, which is of course no reflection on my great support for their efforts going forward. But eLife was created now almost 8 years ago because the leaders of the major funding organizations, the Wellcome Trust, Max Planck Society, and the Howard Hughes Medical Institute, felt that their investigators, indeed investigators around the world, were having a great deal of difficulty publishing in the so-called high-profile journals. journals that very unfortunately were reinforced by a number that I consider a phony number called the journal impact factor, which those participating in this webinar will surely be aware of. The problem is that the journals specifically Cell, published by Elsevier, Nature by Springer Nature, and Science by the AAAS in the US, have a business model, a very expensive business model that relies on the great exclusivity in the selection of their papers. This makes the whole process very much more expensive. And with the advent of open access, those models are now being challenged, and I'll come back to that later on. But let me describe what we've done at eLife. So we launched eLife now, beginning publishing about six and a half years ago, and the model was to create a more open system. Not only open access, we have the CC BY gold standard open access publication, but also an open system of review in a way where the reviewers post their remarks for each other to see, and then there's a consultation discussion among the reviewers to render a final opinion about what the merits of a paper and what needs to be done going forward. So this has been adopted. I think it's quite successful for us. Other journals have modeled it in part, and as a result, we publish now over 1,000 papers a year. For the first 4 years or so, publication in eLife was absolutely free, and I wish that we could have maintained that standard. On the other hand, unfortunately, the founding and funding agencies that supported the journal expect us eventually to become self-sufficient, and it costs money to publish a traditional journal, even if it's exclusively online. There are electronic expenses associated with hosting manuscripts and publishing papers. We are using the funds that were invested in us by these organizations to create open source systems that have, in the first instance, replaced the traditional online publication format. Highwire Press is used by many journals as a hosting system for publications. We have created an open source replacement for that, which for the time being is called Continuum, which we think will be available in the future to other journals to use, which will greatly reduce the publication expenses associated with the electronic medium. We are also very busy working on a system to replace the manuscript hosting system, which is a very expensive element for most journals run by scientific societies. There are just a few commercial concerns that have a manuscript review hosting system. One that we use is called eJournal Press. It's used also by many journals, including the Proceedings of the National Academy. It's very expensive. We hope to replace that within the next year with our own open source system, which again, we hope to make available to all other journals, which will, we believe, greatly reduce their costs. One alarming concern to me, it should be of concern to everyone, is the publisher Elsevier, really an avaricious commercial concern with the highest profit margin of any corporation in any industry in the world, something like 34%. Elsevier recently purchased one of the other major manuscript hosting systems called Editorial Manager, and it is part of their aim, frankly, to control all information, all of the scientific literature. So it is absolutely crucial that we succeed in our venture to create an open source system for manuscript hosting. And I will add that PLOS, the other major open access journal family of journals, tried unsuccessfully after spending millions of dollars to create their own manuscript hosting system, and they find themselves now in the very uncomfortable position of having to pay fees to Elsevier to host their manuscript review system. So this is a subject that doesn't get a lot of discussion among scholars and scientists, but it is a crucial one, because scientific societies, given the push for open access, will find themselves in the position of having to absorb a lot of expenses that ordinarily would be covered by the subscription, but which I will argue later on is likely going away. Now, we have been thrilled with what Cold Spring Harbor has done with the bioRxiv, and we at eLife are linked as closely as possible to bioRxiv. We absolutely encourage, indeed, we request that our authors post their work on the bioRxiv. We have no problem with posting of the final reviewed product after our review process on bioRxiv or anywhere else for that matter, and we would challenge other journals to do likewise, to allow the final reviewed and published form to be posted on any archive or on an individual's website. Now, since the subject of discussion today includes the question of reproducibility, this is one that has been of great concern to us at eLife and in general. Just to provide some of the background, in the biomedical sciences, the problem of reproducibility has been so severe, so serious, that drug companies, a major biotech company in California called Amgen, found that they could not reproduce 85% of the key observations that were published in high-profile papers, probably in the journals such as Cell, Nature, and Science. 85% of the observations that they may have relied on for drug discovery in cancer chemotherapeutic pharmacy. This is quite alarming, and could challenge funders, government funding agencies, to question their investment in biomedical science. Now, I've argued elsewhere that the journals bear responsibility for a lot of the pressure that comes to publish in these very selective so-called high-profile journals. And I'll give you one example. The lead investigator from Amgen, who conducted the study on behalf of the company, found an opportunity to meet with the corresponding author of one of the papers that they had trouble with at a cancer biology meeting in the U.S. And the fellow said to the investigator, "Look, we've attempted to reproduce your experiment 50 times and it never worked." And the investigator, the corresponding author of this high-profile paper, said, "Well, we did the experiment 6 times. It worked once. It fit the story better, and that's what we published." This is an example of I feel, the enormous pressure that investigators have to publish seemingly stunning results in journals that favor these unusual stories and select things that are going to create a sensation, going to generate citations, which will increase their impact factor. And so as a result of pressures like that, we teamed up at eLife, we teamed up with an organization called the Center for Open Science to consider a number of papers more recently published in the cancer biology area. These papers were selected by the Center for Open Science, who obtained a small grant from an organization called the Arnold Foundation. And then they, at the Center for Open Science, lined up a number of contract and center laboratories at universities and private concerns to commission them to reproduce key observations in these papers. They did so in two stages in concert with us in publishing this work. The first stage was that the contract laboratories, in contact with investigators who published these original papers, identified the key experiments that they would wish to reproduce. And after a period of back and forth, they wrote a paper that's called a registered report. A registered report describes the protocols that will be used to attempt to reproduce the published results. These registered reports were reviewed by our editorial board in concert with specialist academic reviewers that we obtained, that we secured. And they went through a rigorous review process, if only to see that the experiments were going to be conducted in a proper manner. So we published, after some back and forth, a number of these registered reports, and the contract laboratories were then given authority to carry on with the investigation. And those now reproduction studies have been published. They're still coming in. The results are not quite as alarming as Amgen reported. In this case, we're actually publishing the results, whereas Amgen did not feel that they needed to publish the results because it was for their own benefit. And we've learned a number of things. First of all, we've learned that reproduction is not straightforward. It's not black and white. It's not that some people are committing fraud and others are scrupulous. It's some protocols are incompletely described in the original papers. Some conditions cannot be met. Reagents and antibodies and cell lines change with time. So reproduction is a very complex process, but it's clear from our experiment that there is a challenge in very complex situations that call on investigators to be more open in exactly what they've done. So we've done this, and this project continues. It's been enormously time-consuming for us, but I hope the community has learned something about this. Now let me conclude then with more remarks about the open access situation. First of all, let me go back to the concern that Umberto mentioned at the outset, and that is the trend in Argentina to favor going to subscription journals because of the cost of publishing in open access journals, the article publication fee. I hope this is only a temporary trend in Argentina. I think it's not a good sign that people are returning to subscription journals and away from open access journals. We at eLife, and I think most other journals that offer eLife offer open access option, will defer or excuse publication fees from investigators who have inadequate funds. So for those potential authors of eLife papers in Argentina, please don't decide against submitting a paper to eLife just because you don't think you can afford it. That should be the last reason to think about whether eLife is an appropriate venue for you. We will excuse publication fees for those investigators who have inadequate funding. But let me return now and conclude with remarks about what's happening in open access. I think you're all aware of, in particular, the initiative in Europe for the European Union is in the process of developing a policy that will essentially mandate some form of gold standard open access publication for investigators funded by many of the European Union countries. This is, I think, a wonderful policy statement on the part of the European Union. It has been taken up by the Wellcome Trust, who just recently have agreed to impose the same conditions on their investigators. And I can tell you that other funding agencies, including the Howard Hughes Medical Institute, are considering doing the same for their investigators. So the ground is shifting on the commercial journals and the journals published by scientific societies. It is inevitable that open access, and indeed the gold standard open access, will take hold for, I think, increasingly all of the biomedical literature. And I think this is a great trend because, after all, most of the science that we and everyone does in the biomedical community is funded by public agencies. And I feel very strongly, I think most people agree, that should be available for all to see free of charge. Of course, as I've indicated, publishing costs money. There are many other things that are required, at least in the traditional model. And I'm hopeful that those expenses can be lessened by some of the electronic initiatives that we're doing at eLife. And for those commercial concerns like Elsevier and Springer Nature, I think they are increasingly under pressure to find alternative ways to make a profit for their shareholders, or in the case of Springer Nature, to make profit for the family, the von Holtzbrinck family that owns the whole thing. They will not be able to continue to, frankly, to extort the scientific community for profits. They will have to modulate their ambitions and conform to the inevitable open access trend that will take over biomedical science. So I'm happy to stop and take questions if there are any.
Okay, thank you very much for your presentation. We have a couple of questions. Two of them are kind of related. Could you explain some of the initiatives that you have encouraged in eLife regarding ECR researchers?
ECR.
Early career researchers.
Yes. Okay. So we have all along been very concerned about making eLife an exciting venue, particularly for beginning investigators. We have right from the outset, we said we would give an edge to beginning investigators in at least in deciding whether a paper is reviewed. We had a policy of writing letters on behalf of graduate students or postdocs who were first authors on eLife papers to help them secure fellowships or jobs. And then as time went on, we decided to engage a group of early career scholars as an advisory board to us. So they meet when the editors meet, and they discuss in a group along with leadership members of the leadership team those things that are particularly of particular concern to early career scientists. We have created a large group of early career scholars to serve as an adjunct to our editorial board, and we are trying to find ways to have these people and this roster known to those members of our board who are charged with identifying referees. These are a large resource of scholars who are rarely asked to review papers or to edit papers, who are obviously talented and successful and would be willing to help us. So we're working hard to try to bring more of those people into the review process, to give them experience and then for us to gain from their knowledge. So this is a big deal for us.
Okay, we understand that you are very soon stepping down as editor-in-chief of eLife. I wonder if you could highlight some aspect that you value more of your experience there, or the legacy that you think that you're going to left.
I'm stepping down not because of any displeasure with the journal or the commitment that I've made to it, but I'm starting something new. For personal reasons, I've become very interested in Parkinson's disease. My wife died last year of Parkinson's disease. And I've been approached by a representative of the Sergey Brin Family Foundation. Mr. Brin was a co-founder of Google. His mother has a genetic form of Parkinson's disease, a dominant allele of a gene called LRRK2, and he has regrettably inherited this mutation. He is not ill yet, but he is at some risk. He, of course, with his wealth, has been keenly interested in supporting research on Parkinson's disease. And he's decided now to make a commitment for a 10-year project funded with $1 billion of his own wealth to identify key objectives in moving that research, basic science on that disease mechanism forward. And so I will shortly step down from eLife to take on the role of the director of a virtual institute, I hope an international institute that will find investigators and link them together in a network of those concerned with pushing the needle forward on that disease. But I look back with I would say mixed emotions about eLife. I believe it's been successful. I'm quite happy with its impact. I'm particularly pleased with the review process that we developed, this more open and consultative approach, which I think produces a more refined decision letter for authors. Since the reviewers have to be identified, at least to each other, I think it eliminates the tendency of a referee to hide behind his or her anonymity, and that person must then be in a position to defend his or her comments in a discussion with peers. I think that's for us has been a really good thing, and I hope other journals do that. I'm very confident in the leadership team at eLife carrying on. As I step down, they are in the course of trying to identify my successor, and I know there are a number of really terrific people who are being considered for that position. So I think eLife will continue to have an influence, but I have to say the frustration that I've had all along is the obsession that investigators have around the world with publishing in these journals that I referred to in that Guardian editorial as the luxury journals. Luxury journals which have a business plan that favors the creation of this kind of exclusive club that people feel they have to join if they're to have a successful career. This, I think, has exerted a toxic influence in biomedical science, and it creates the feeling that if you're not working on certain selected popular areas, you're not doing anything of interest. It's a distortion. It's a distortion of what I remember when I was a graduate student as what we considered important moving forward has now become the domain of professional editors who are frankly in the business of selling magazines. And in spite of my best efforts, I don't think that culture, that toxic culture of feeling that you have to publish in these journals has diminished. And it's all over the world, and it's pervasive. Scholars are paid cash rewards just for winning the lottery to publish in a journal like Nature. I think this is a terrible tendency, and I hope that the community moving forward moves away from the use of this ridiculous impact factor, and then moves away from the feeling that they have to publish in only a few small, highly selective venues. So, but you know, things will evolve as they will, and I will continue to, even after I've stepped down, I will continue to argue against the influence of these journals.
There I have some. Thank you very much for your answers, Dr. Schekman. It was a pleasure hearing your presentation. I'm going to move forward to our last speaker. It's a pleasure to introduce you to Richard Sever, who is an assistant director and executive editor for CSH Perspective and CSH Protocols. The CSH is the Cold Spring Harbor Laboratory Press, which is an international renowned publisher of books, journals, and electronic media located in Long Island, New York. CSH has furthered the advance and spread of scientific knowledge in all areas of genetics and molecular biology, including cancer biology, plant science, bioinformatics, and neurobiology. Dr. Sever is the co-founder of bioRxiv, the most important preprint server in the life sciences, which today contains over 32,000 articles of more than 100,000 researchers from more than 104 countries. bioRxiv is growing exponentially and serves as a hub that connects pre-publication discussion of new results with formally published journal articles, also encouraging new initiatives that aim to rethink and improve the peer review process. As a highlight, in an editorial published over 14 years ago by Dr. Sever in the Journal of Cell Science, entitled Nonprofit Publishing, Open Access and the End of Copyright Transfer, he promoted open access as an online publishing model, joining the Hinari Initiative, which gives third world countries instant free access to the scientific literature and supported the shift away from copyright transfer practices. Ladies and gentlemen, Richard Sever.
Hi, can you see my screen okay?
Yes, we can, thank you.
Okay, you're breaking up a little bit, so tell me if my if you can't hear me. So yeah, thanks very much. It's a pleasure to talk with everybody. It was great to hear Randy and Casey's presentations. So I wanted to talk a little bit about bioRxiv, but the first thing I wanted to say was that bioRxiv is an initiative of Cold Spring Harbor Lab. And for those of you who don't know, Cold Spring Harbor Lab is a research institute in New York with 600 scientific staff, a focus on molecular biology, cancer, neuroscience, plant biology, and genomics, and over the years has really had a kind of immense research impact with numerous Nobel Prizes for things like the work of the phage group, Fred Hershey and Martha Chase's work on DNA, the Nobel Prizes for splicing for Rich Roberts, and obviously as plant biologists you would know Barbara McClintock and her work on transposons, and of course Carol Greider also had the Nobel Prize for her work on telomeres. And Mike Wigler, of course, discovered the RAS oncogene. But there's another part of Cold Spring Harbor's history, which is science communication, which we've been doing for a very long time. And this is just a photograph of the first course held at Cold Spring Harbor in 1890. And over the subsequent 130 years, the science communication has evolved. We have a conference program that brings 8,000 scientists through Cold Spring Harbor every year to learn about the latest findings. We have a graduate school, residential lab and lecture courses here in Cold Spring Harbor, and a publication program that includes molecular cloning, the sort of the Bible for molecular biologists that most of us had on our lab benches for several decades, various textbooks, history books, and most recently bioRxiv, the preprint server for biology. Now, so bioRxiv launched in 2013, and I should just clarify exactly what I mean by a preprint. So what we mean by a preprint is an unpublished manuscript that is yet to be certified by peer review. So it's a paper that the author has written, but they've yet to have it published in a journal and have that sort of authentication, that certification, that evaluation process sign off on the manuscript. So what the preprint server is really doing is decoupling the dissemination of the work from its subsequent editorial certification, which offers a number of opportunities that I'll talk about later. There's a big precedent for this, of course, which is the Physics Archive, which has been going for 27 years, has more than a million preprints, and is basically, you know, very much accepted within that community. And so bioRxiv was really, the mission was to bring that culture to biology. bioRxive's a non-profit service of Cold Spring Harbor Lab, you know, to the point about the cost of this process. Everything is free. It's free to submit, free to read. The papers are screened to check that it's science and it falls within scope and that they are research manuscripts, but there's no peer review because of that decoupling. And the focus is on the biological sciences with the intent to complement archive. So the question is, why would one do this? Well, the real mission is to speed up transmission of results. It's clear that the current publication process is really not compatible with the rapid pace of science these days, and a preprint allows you to get your work out immediately and have the author control when the research is disseminated. It's also an opportunity for authors to get pre-publication feedback on their manuscripts, and you can see from one of the tweets shown by Sri Kasuri that, you know, that's an example of people getting feedback on the preprint that allows them to improve the paper, so that when it's finally published in a journal like eLife, it's in a better state. This early dissemination is particularly important for early career scientists because the timeline of their careers of research fellowships, of postdoctoral fellowships of 3 years can leave them treading water as they wait for publication. Whereas if they have a preprint out, then they can use it as evidence of visibility, make it available to grant committees, hiring committees, tenure committees, and indeed there are already examples of people who've got jobs based on the dissemination of their preprint. And there's an example of Nikolai Slavov from Northeastern University, provided who got his paper appeared in several reports, but he actually got the job based on the preprint that had been on bioRxiv first. this curve just really makes the point in terms of the numbers. If you look at the blue curve is showing you the average times from submission to publication of journals in PubMed. And you'll see the median is around 6 or 7 months, but that range goes out to 2 to 3 years. And that's 2 to 3 years of time that could have been spent with other researchers building on the work if it had been disseminated early. And of course, on the far left, you see bioRxiv, which is disseminated in 24 to 48 hours. And obviously that huge time saving for research. And there are many examples of this in the top right of the screen. You can just see a recent paper that I picked up from Nature, paper submitted in September of 2015, finally appeared in Nature March of 2018. So that's 2.5 years later. So, and you know, this has a significant effect on people. This chart just shows the trauma that an author goes through in this process. On the far right, you can see towards the end of 2016, Stephen Royal posted a paper on bioRxiv, and then he shows the subsequent progress from submitting to a journal, multiple cycles of rejection, resubmission, revision, new reviewer demands, and ultimately publication a 1.5 years later. And this has a tangible effect on research. Here's an example from my former colleague, Mike Fagan, who's now a young PI himself, and he shows the timeline of research of a recent collaboration. He saw a paper midway through last year on Twitter that had been posted on bioRxiv. There was some discussion on Twitter. As a consequence of that, he was able to start a collaboration with the author of the paper during the fall of last year, start sharing resources, develop a series of experiments. And come January of this year, they actually started harvesting cells and doing DNA analysis from the follow-on work together. So they were getting results from the follow-up experiments in January of this year. In January of this year, the paper that he first saw as a preprint 7 months before was finally published in a journal. So he had a 7-month head start. And for a young PI who has 5 years, 5 years to make it, a 7-month head start is significant. And if you add up all those 7 months, you can imagine it's a huge benefit to science to speed things up like that. Steve Quake at the BioHub in San Francisco has done some back of envelope calculations where he shows that if you make various assumptions about the time delay to publication, the delay it takes for somebody to see it, and you aggregate those with some estimates of how many ideas it takes to stimulate a new discovery, you can kind of rapidly get to an approximation that over a period of 10 years, if everybody posts their manuscripts as preprints, you could speed up scientific discovery 5-fold, which is pretty significant. So moving more specifically to bioRxiv, what do you get for posting on bioRxiv? Well, the main difference with a journal, of course, is it's just the author PDF. You submit a PDF, that is what goes online. There's no typesetting. We'll be augmenting that with full text HTML in a few months' time, in particular to allow better text mining. The manuscript is date stamped, so you have that priority stamp, which is kind of related to the point Casey made earlier, and it's given a DOI so that you can cite it, and it has a persistent identifier. The author chooses the subject category, biochemistry, cell biology, neuroscience, etc. The type of article, so most articles are new results, but because we're concerned about reproducibility, and that's a point Randy mentioned, we also have categories of confirmatory and contradictory results so that authors can post papers on reproducibility. And then another big difference from a journal is that a revised version of the preprint can be posted at any time. Once the paper's online, they're indexed in Google Scholar, the Meta Discovery tool, and Microsoft Academic Search. So that's the best way to find papers. Each paper gets article level metrics, so the authors have numbers for how many times the paper's been viewed and downloaded. Alt metrics show how many times it's been blogged about, the news coverage, other social media discussion, and we have commenting on site to encourage feedback to authors. Again, we're very keen on that, as Casey Greene mentioned. And we also provide links, forward links to the published version, so that readers are pushed to the version of record when that appears. So authors can be reassured that when they publish in a journal like eLife, if somebody discovers the paper later on bioRxiv will say, hey, this is now in eLife, you can go and read the final version there. And we also link to online discussion elsewhere, and I'll come back to that a bit later, but that's a link again to Casey's point about bioverlay. And so this is just a quick look at the site. You can see it's essentially a list of articles, and on the right-hand side, you can see the different subject areas that the author chooses. I've just highlighted the DOI link here and the link to download the PDF, and just an illustration that when you bring down the PDF, what you're seeing is the author's PDF, and this is just one example. The history tab gives you the article history, so you can see all the previous versions that the author has posted and track the evolution of the manuscript. And as I said, we provide metrics on use of the articles. The link forward to a journal, to the journal when the article is subsequently being published. This example is subsequently published in Nature. Comments below the abstract, and as I said, an aggregation of links to online discussions that are happening elsewhere. And these can be it preprint discussion venues like bioverlay, and in this case Prelights, to blog posts about the article, and a scrolling list indicating Twitter discussions, of which there are many. So how are we doing? This shows the growth of bioRxiv over the past 5 years. The black line is the total number of posts. We've got exponential growth. There's now 34,000 papers. The red bars show the submissions per month. We're now at around 2,000 a month, with about 30% revised versions. Some more numbers here. As I say, 30% of papers are revised at least once, many several times. We now have more than 150,000 people have been authors on bioRxiv papers. 4 million people are viewing papers on bioRxiv a month. And the majority of those papers go on to appear in journals. It's difficult to get precise numbers because obviously there's a time delay before publication, and some papers change title and author lists, so you get some false negatives when trying to calculate that number. But we get a 60% figure after a 2-year delay. I think Archive gets 70% after 5 years, so it's in that ballpark. And indeed, more than 1,500 journals have now published papers that first appeared as preprints on bioRxiv. We've seen significant cultural change over this period. There's a lot more biologists are now posting preprints. 5 years ago, there were a lot of journals that did not allow you to do this. It's been really encouraging to see the changes in policy over the past 5 years since bioRxiv was launched. So it's now safe to say that in basic science, most journals will allow you to post a preprint. Funding bodies are now allowing you to cite these in grants. And a really nice aspect is that we're beginning to see more recent data being presented at meetings, because there'd been this trend for people to wait until the publication before they talked about a paper, but now they can post a preprint and get a marker down, and so we're seeing people talk about more recent work at meetings, which was something we hadn't foreseen, but it's really fantastic to see. In terms of online conversations, there's a small number of, so we 10 to 15% of papers on bioRxiv get comments on bioRxiv. It feels kind of low, but it's actually much higher than journals that have commenting sections. And I think that reflects the fact that it's not a final version of a paper, so you have an opportunity to affect the trajectory of that paper and help improve the paper. And some of those discussions are very extensive and really interesting to see. There's also a lot of discussion on Twitter, more than 100,000 conversations on Twitter about bioRxiv papers per year. And in some ways, the big unknown is email, because authors get a lot of feedback on their bioRxiv papers via email. It's hard to quantify, but we did a survey recently, and something like 40% of authors said that they were receiving feedback on their papers via email. So that's great to see. And in general, I think what we want bioRxiv to be is a hub that allows other things to happen afterwards. These types of conversation, discussions about reproducibility, publication in traditional journals and new formats. So the most obvious thing that happens afterwards is publication in a journal, and so we really want to make that easier for people who posted on bioRxiv. So as Randy mentioned, we have this technology called B2J, which allows an author who's submitted to bioRxiv, once they've submitted the paper, to select from more than 100 journals that they would like to submit to, and they can just click on the journal they want to, and it will send all the files through to that journal, and that saves the author the trouble of having to go to the journal website and load up all the files and enter all the metadata again. A smaller number of journals also allow things to go the other direction. So you can, for example, when you submit to eLife, as Randy mentioned, you can click a button saying, you know, I'm aware the peer review process is going to take a while. Can you put my paper on bioRxiv right away so it's out there? And both of those have proven to be extremely popular with authors, as has the editorial prospecting we're seeing, which is editors looking at bioRxiv, finding interesting papers, and then contacting the authors and saying, hey, you know, I liked your paper, can you submit it to my journal? And this is just a tweet from actually a long time ago from Leonid Krugliak, who saw this beginning to happen. And as I say, that is very popular with authors, as you can imagine. Some of the conversations will happen at conferences, so we like to integrate with conferences and create conference channels where conferences can list all the papers on bioRxiv that are related to presentations or posters at the meeting. And actually, we now allow authors to produce QR codes for their papers. So I was at the American Society for Human Genetics recently, and they had a great system where we printed out a QR code, and authors would put it on their posters so that somebody could go and see the poster, be interested in it, and then take a picture of the QR code so that they could go back to their lab and show everybody the preprint. And then that was extremely popular. As I said, we also want to link out to other discussions that aren't happening on bioRxiv about papers, and this includes highlighting services such as pre-lights from the Company of Biologists, pre-review, which is like an online journal club for preprints that is particularly good for training young scientists in peer review. And then there are things like academic karma and peer community in, which sort of begin to resemble journals a bit more. It's, you know, there's some way between a journal and one of these discussion sites. And then, of course, there's PubPeer we also link to. That's an online journal club that's been going for a while. And the same guys behind PubPeer have recently released a thing called Periodicals, which is a way of kind of sort of building your own journal that we link out to. And we want to kind of encourage these and make and direct people to conversations that are happening here in the same way that we direct people to the more traditional journals. And as I won't talk much about this, but Casey mentioned BioOverlay, and this is probably the most formal example of such a new initiative that really begins to look a bit more like a journal. And I think the other thing to think about is that the publication in traditional journals is evolving. And so we have a project called PLOS, which is to really talk about how can we rethink peer review based on the idea that the preprint is already out there. So what we're planning to do with PLOS, and we're still in very early stages of this, is enable a badging system by which when an author submits a paper to PLOS, it's immediately posted to bioRxiv. And then in stages, PLOS do the evaluation, the editorial and peer review evaluation of the paper, and then we'll send signals back to bioRxiv, providing information about bars that the paper has now passed. And just to make sense, you could imagine that the statistics may be evaluated earlier in the process than other aspects of the science, and so you could have a badge saying the statistics have passed various tests, or various ethics checks or image checks or methodological checks are being performed. So I think that that's really interesting, because it shows how bioRxiv ends up being a kind of like a platform to allow people to experiment with the evaluation that comes afterwards. And so, you know, and all this kind of leads me to think that I mentioned bioRxiv as a hub, and I think Michael Hoffman, a Canadian researcher, put it quite nicely recently, when bioRxiv has really great uptime, but it did go down for a very small period of time, like an hour or so, a few years ago. And Michael pointed out that, you know, the fact that it had gone down and people were noticing suggested that we've gone from being an experiment to a utility. And I think that's really how we'd love to think of the project, as something that really allows other people to do it, to experiments, and make the rest of that kind of publication evaluation system operate more efficiently. Just to thank a few people. There's a large team of people at Cosman Harbor, the bioRxiv team, who make this all happen. It doesn't all happen by itself. We've got great technology partners in the Stanford spin-off Highwire. Our funding is from Chan Zuckerberg Initiative, and I single out Jeremy Freeman and Corey Bargman for being great advocates and really fantastic collaborators in helping with the project. They do a lot more than just fund it. We have a great collaboration at Google. Anurag Acharya is head of Google Scholar, we've been working with. He's been fantastic. And then the leadership at Cosman Harbor and Bruce Stillman, his support has been critical. And I'd single out one of the faculty, Justin Kinney, for all his work on the project, and Robert Lurie from the Lurie Foundation, who gave us money for the project early on. And there's a very large number of bioRxiv affiliates who are PIs in many different labs around the world, who act as a sounding board and help us screen manuscript. And really, bioRxiv couldn't function without them, so I can't thank them enough. And then finally, I'll just end with a little bit of an advertisement, which is we're going to be launching medRxiv probably in January of next year to try and bring this culture to clinical research. And for anybody who's kind of not sure about whether the clinical community needs this, I just wanted to point out that in 2003, when the SARS epidemic happened, 93% of papers were published after the epidemic had ended. In 2016, when we had the Zika outbreak, you were seeing preprints with new data appearing in the midst of the epidemic. So we think that medRxiv will be as valuable a service to medicine as bioRxiv has been to biology. So that's all. Thank you. So I can't hear you, Humberto.
There you go. Thank you very much for your talk. We have many questions. I'm trying to integrate a few of them. For example, you have mentioned the batches, the possibility of using batches to recognize good practices in science. You cannot hear me? Hello? Hola? Hi?
Yes.
Can you hear me now?
I can hear something now.
Okay. What about now?
It's very poor quality.
Let me try again.
Oh, now I can hear you.
You can hear me now?
Yeah.
Oh, sorry. Well, I'm trying to integrate a few questions we have. You have mentioned the use of batches to recognize good practices in science, such as data availability, statistical checks, and also you have mentioned an exponential growth of the submissions to bioRxiv. Are you able to, I mean, do you have the infrastructure to keep having that screening that you have following this exponential growth? Do you think that if you start including more screening, then the cost will increase, and then you could have some problems there? I don't know if it's clear, my question.
Okay. Yeah, so our process is all developed with the idea that it will scale, so that everything we do is based on the idea of trying to do all things that are automated, or things that will scale with people. So, you know, we have, I think our list of bioRxiv affiliates is 100 PIs involved in screening. And you know, that will handle like 100,000 papers in a year, for example, we think. Now, there are a lot more, we can build that because there are a lot of scientists. So we think that you know, it's not a staff-based screening mechanism. And I think that's why one of the things we're very keen on is focusing on this dissemination mission, because as Randy knows from running a journal, the administrating peer review, editorial time, all of that takes a huge amount of time. But of course, bioRxiv doesn't do anything, and it's just doing the dissemination. And we feel that so long as we stick to that mission, and then we can scale. What we want to do then is use technical tools to allow us to do things that help journals and other evaluation mechanisms later. So if we can convert, we're converting to HTML, and then we can give all the HTML to the journals, for example. But the key thing is that what we can scale, because we're not doing the intensive peer review and editorial, which involves people.
Hello? There you go. One question here is if preprints are successfully integrated with peer review collaborative platforms, will there be any need for journals?
Well, so I think that in some respects, I think there's a bit of a kind of like false dichotomy there, really. You know, I mean, I think if you find that you have a preprint evaluation platform, and you're doing peer review, and you have editors, and you're asking authors to make changes, and they're making changes in response to the deliberations of the peer reviewers and the editors, then I would argue that you kind of have a journal. So I imagine that there will be some convergent evolution in people's thinking there. And I think the issue for me has always been what percentage of papers go where. So I think, you know, my feeling is that the very high quality papers that need a very thorough consultative review process of the sort that Randy described, I don't think that is going to go away. You know, I think that's important for many, many reasons. On the other hand, it's possible that we may decide that there are other scientific contributions that perhaps don't necessitate such extensive editorial and reviewer input. There may be a more less significant advances where the reader can judge it themselves. But I think, you know, ultimately funders want work evaluated. People who are in fields a little bit distant from it want work evaluated. So you know, so I don't think the field's going to stop needing people like Randy anytime soon.
Okay, thank you. And another one is, well, it's raised all the time about risk associated to preprinting as a two-sided sword, where there are some concerns about the scooping, or that preprinting could induce the deposition of preliminary data for flag planting. I wonder what's your opinion about that?
So I think, a couple of things. I think scooping, you know, it's interesting talking with the physics community who've been doing this for 27 years. So, you know, their response to the scooping question is, how can you be scooped if what you're using is an anti-scooping device? You know, you put the paper out there, by definition, you can't be scooped. I think what it does mean is that one needs to have a conversation about, as you imply, between, you know, what happens if the thing you put out there isn't complete. And what you see in the physics community is that everybody knows in academia, your reputation is key. So what happens is if you keep putting out preliminary papers and claiming that you're the first to do something, then the academic community has a reputation system that is very, very efficient. And your reputation will not be for somebody who's first. Your reputation will be for somebody who posts crappy, incomplete things. So I think there's a certain element of that. I think that the bigger problem for scooping is when you talk to a lot of people about scooping, you realize what they really mean is not about priority or being first. What they're really worried about is that if they post something on bioRxiv, somebody will read it very, very quickly, go and do the same experiments, publish them somehow secretly in Nature, and that will stop person A being able to publish in Science, because Science will say this is old news. I think that's what people are really worried about, and that's why I think it's great that journals like EMBO and Development are doing things like they say, we have scoop protection. If you've submitted a paper to us, if something comes out during the time we're reviewing it, we are not going to reject your paper and say it's old news. And I think if journals, and I think Development and EMBO extended that to preprints, I think if more people can do that, then it's the most honest way to go about this. Because the other thing about the priority signal is the random sort of stochastic nature of the times of journal peer review means that if we talk about priority dates based on journal publication, then there's a huge amount of noise and randomness that leads to who's first. Whereas if you put it on bioRxiv or archive, then the author is in control of the date of the dissemination. Now, the journal may be the entity that retrospectively certifies that you did it on that date, and you may need to wait for the journal to say, yeah, they did do that, you know. But, you know, so again, it's back to that point about decoupling dissemination and certification. I also think, just as a general point, I think Randy was at the meeting and will probably, you know, being a Nobel laureate, has better insights into this than most people. But one of the comments the president of Cold Spring Harbor made about the scooping question at the first ASAP Bio meeting was, he said, you know, when they decide who gets the Nobel Prize, they don't just go and look at the publication dates in a journal. You know, it's a much more complicated. So I feel like the academic community has really created this bogeyman of scooping that they're terrifying a lot of graduate students and postdocs with. And it's funny when you talk to a lot of people about it, when you ask them, okay, can you give me some real concrete examples of people who were scooped and how this kind of totally ruined their careers? The number of examples that people provide, I mean, people always say, oh, well, it nearly happened. And I find it's very hard to find people who can give really concrete examples of when this actually happens. And hopefully we can move to a point where everybody just puts their stuff on bioRxiv first and the whole debate becomes moot.
Sorry, we cannot hear you. Oh, gosh.
Okay, can you hear me now?
Yes. Now it's okay.
Yeah, I have two things. One comment. First of all, Richard, I fully support the idea that scoop protection should be offered by all journals. We've been doing that all along at eLife, and the journals that don't offer that, really, we should not publish in those journals, quite frankly. I have a two-part question for you, Richard. You will post revised versions on the bioRxiv. Will you post a manuscript, the PDF, that is identified as having been accepted?
No, so we don't post it. So our solution for that is to link. So what we do is we have scripts that will go. So when eLife accepts a paper and publishes it, then we have scripts that crawl PubMed and Crossref will find the paper and link through to eLife so that we link to the version of record where it is. What we don't want to do is end up doing things like assign preprint DOIs to papers that already have journal DOIs and muddy these differences. And so that's why we think linking rather than posting is the best solution there.
I understand, but the problem is sometimes with journals, it takes a long time after a paper has been accepted before it actually appears. So
yeah, so we have one group of, so that the solution I always then say to authors is what you should do is post every version of your paper on bioRxiv. Then when it's accepted, you know that the accepted version is already on bioRxiv. And so one of the things we do now with the American Society for Microbiology is because they have, eLife has a very fast publishing time, so it doesn't matter too much, but I think ASM have a bit longer. So one of the things they do now is they will send us a feed of accepted papers. So before it's published, we will actually have a little label on bioRxiv saying this manuscript is now accepted in this journal, and that bridges that gap that you're talking about. And then once it's published, that link is then replaced with a link saying go read this at.
All right. So the last thing that you just said provides an opportunity to, in a way, defeat the embargo policy of those commercial journals that will not allow an accepted paper to be posted anywhere else.
I guess so, but I guess the point we would argue is that the point if the point that it was posted on bioRxiv, it was not accepted. Do you see what I mean?
No.
So it was there. It was there already. And journals have different journals have different policies on that, and that's a kind of conversation for them to have with their authors. We have those sort of technical reasons for this, and I think for journals that are open access and have fast publication times, it becomes academic.
Okay, thank you.
Oh, I'm not hearing Humberto.
Can you hear me now?
Yeah.
Yeah. Can you? Okay. One question about bioRxiv and the concept of complete work. There are some trends about the micro-publishing, which is like a kind of publishing results per results and then integrating all that into an article, but doing that like in a timely fashion. And on the other hand, in bioRxiv, you have a policy of complete articles. In fact, sometimes in Twitter there is some finger pointing to articles that do not have method section, etc. I wonder what's your personal opinion in these matters.
What we have, one of the things that we have in bioRxiv is there's a lot of areas where there's kind of like a spectrum of opinion, and what we try to do is steer the most kind of practical middle ground that works the best for most people. So I think there are places like Figshare where you can simply put up a figure, and they're great, and that's almost like a micro publication. But I think for our purposes, there's a potential 1.5 million research papers per year. If you suddenly say that you're going to have micro publications, is that 15 million per year? Is it 150 million per year? And the narrative about research papers currently, most authors, most scientists I talk to, all the scientists I talk to at Cold Spring Harbor, the vast majority of scientists that I know, they feel that a paper is a narrative written about a series of experiments, and it makes sense for that to be the unit of dissemination. And I have a lot of time for that, and so I'm not in a great rush to put micro publications out there. I think there may be for those. There are databases, There are places like Figshare, and I think that makes a lot of sense. I think we feel for bioRxiv, it would kind of be mission creep, and I'm not sure it would be better for most people. As regards the methods, that's a tricky one. I think the aspiration and the advice is that we want people to include the methods. The question is if you're screening and we get 2,000 papers a month, we have days when we get 100 papers a day. You know, every now and then it's difficult, and some papers it's difficult to know what sometimes the methods are in the supplementary data. Sometimes it's not clear if it's a complete method, and fundamentally to assess whether it's a complete method, you need to do peer review, and then you're back to the value that something like eLife provides. Because the one thing I go is, you know, I can write a method section and put it on bioRxiv, but you know, a bad actor can write a method section and leave out things, and only peer review will know what's been left out. So in many respects, one of the interesting things about a couple of papers that were pasted on bioRxiv without method sections was immediately there was a big discussion on Twitter about this. You know, the author was contacted by various people, and then the next day they submitted a new version on bioRxiv, which you could, with the method section. So a lot of people said, there you go, that is the system at work. And that goes back to the point I was making about the sort of academic trust network. If you get a reputation for being the person who keeps on putting up papers without methods, then it won't help you. So I think, you know, so I have a lot of sympathy for people who say, actually, you know, this is the most effective way. This actually illustrates the huge value of something like bioRxiv, is that suddenly, you know, there are thousands of people who can read the paper and say, look, the method section isn't there. This needs to be complete. And the bioRxiv screen is, I can't say this more strongly. The bioRxiv stream is a coarse filter to try and eliminate, and it's never going to be perfect. But the idea is just to remove inappropriate things. But some things will get through that aren't appropriate, and you know, and that's where the wisdom of the crowd comes in. And those examples you cite of, I think I think they worked very effectively. The author was very, very apologetic about it.
We have time for a last question. It's addressed to Dr. Schekman, but you can also chime in, Dr. Sever. It's like, how do you envision the publishing landscape 10 years from now?
I can answer that. First of all, as I indicated in my remarks, I think open access is here to stay. I think there'll be increasing pressure from funding agencies to publish in open access. So I think 10 years is not a long time. I think journals will still exist in 10 years, but if the evolution favors empowering archives such as bioRxiv, I'm all for it. I think it's easy to see because of the what Richard said, that it's a superior medium. It offers the opportunity for groups to review papers and to post comments. I think it will open up the process. People are going to have to be more willing to be identified as referees on papers that are on the archive. And I think reviewers who are willing to identify themselves will gain the advantage of getting reputation, getting credit for having generated thoughtful, constructive reviews. That's something that's still missing. A lot of us spend a lot of time reviewing papers for which we get very little credit. I think if reviews are signed, posted on something like the archive, and receive a DOI, I think we as scholars should include that in our resumes and CVs, a list of those DOIs, and credit should be assigned for that valuable work. So I think it could very well evolve away from journals, and that would be fine.
Yeah, I mean, I would just echo what Randy said. I think the one thing that I would add is I think we'll see a change in what peer review is, and there'll be a spectrum of activities. So you might look at eLife in 10 years' time, and then there'll be a series of articles, but the way those articles were evaluated may be different depending on what field they're in. So if it's a cell biology paper where somebody has been looking at the secretory pathway, you may find that there's been a period where a microscopist spent some time looking at it in one way, and on a different timeline, somebody who was an expert in sort of snare proteins looked at it in a different way. And then there may be another paper that's a kind of more bioinformatics paper, and that's subject to some continual process of evaluation, and that you'll have something like the eLife will look a lot more heterogeneous in its content and in the way that content has been evaluated.
Okay, I think we are in time to wrap this up. I am truly indebted, and I'm very happy to have hosted you and also Dr. Casey Greene. It was a pleasure hearing your insights of these important matters and in a local audience. So thank you very much for your time. All the best.
Thank you.
Thank you very much. Bye-bye.
Bye.
Okay, bye. Muchas gracias a los locales.